Welcome to the deep dive. Okay, so you've definitely heard all the buzz about artificial intelligence, right? AI.
Oh, yeah, it's everywhere.
Exactly. You hear everything from like magic robots to these predictions that sound, well, frankly, like sci-fi.
World-changing stuff, apparently.
Right. So our mission today is really to cut through all that noise. We want to give you a clear, kind of grounded understanding of what AI actually is.
Beyond the hype.
Beyond the hype. Make you well-informed, fast. I'm going to explain it in plain terms, look at its history, which is longer than you might think.
Definitely.
Pinpoint where you see it every day, and importantly, bust some of those common myths. Think of it as like a shortcut to really getting this tech.
Sounds good.
Okay, let's unpack this. So first things first, what is artificial intelligence fundamentally?
Well, at its core, AI is best described as the ability of a computer system to do tasks that would normally require human intelligence.
Okay, like what kind of tasks?
Things like learning from experience, reasoning about information, making decisions, understanding language or images, that sort of thing.
So it's not like some conscious mind in a machine then. It's more about mimicking certain human abilities.
Exactly. It's about computers performing specific functions that resemble aspects of human thinking. It's not sentience.
Gotcha. And how does it actually do that? I mean, it feels like a black box sometimes.
Yeah, it can seem that way. But underneath, AI systems work through algorithms. Think of them as really detailed step-by-step instructions or mathematical models.
Okay.
These let the computer analyze data, find patterns, and crucially, improve over time. Learn, essentially.
Machine learning, ML, that fits in here somewhere.
Right. ML is a huge part of modern AI. It's a subset.
Yeah.
It's about giving computers the ability to learn from data without being explicitly programmed for every single possibility.
How does that work?
Instead of a programmer writing exact rules for every scenario, we show the computer tons of examples data, and it figures out the patterns on its own.
Ah, okay. So it learns by example, kind of like we do.
In a way, yeah. It gets better and better the more data it sees. And often, nowadays, this involves something called neural networks.
Yeah, I've heard that term. Sounds very biological.
It does. And they are loosely inspired by the brain. They're made up of layers of, let's call them mathematical neurons.
Yep.
These neurons adjust their connections as they're trained on data, give them enough data, enough computing power. And these networks get incredibly good at things like recognizing images or translating languages, playing games even.
Wow.
What's really fascinating here, though, is that AI isn't just one thing. It's not monolithic. It's this broad field, drawing from math, stats, computer science, lots of different techniques.
So the big toolbox, basically.
Pretty much. And its main job, fundamentally, is prediction and recognizing patterns. It's not conscious thinking. It's advanced computation.
That makes a lot more sense. And you mentioned its history is longer than people think. It's not just a 21st century thing.
Not at all. I mean, the ideas go way back. Ancient myths have automaton concepts, and early sci-fi in the 20th century definitely explored it. Metropolis, Asimov's Eye, Robot.
Right, the philosophical ideas.
Yeah.
But scientifically.
Well, you see early glimmers like 1943, McCulloch and Pitts proposed artificial neural networks. Then a really key moment was Alan Turing in 1950.
The Turing test guy.
The very same. His paper, Computing Machinery and Intelligence, asked, can machines think? And proposed that test, to see if a machine could fool someone into thinking it was human.
A classic. So when did it become like a formal field of study?
That really kicked off in 1956, the Dartmouth Conference. That's where John McCarthy actually coined the term artificial intelligence. It's seen as the official launch.
And early programs started appearing then.
Yeah, pretty quickly. Arthur Samuel's Checkers program back in '52 could teach itself, which was amazing for the time. Then you had things like logic theorist, general problem solver, focusing on reasoning.
But didn't someone create an early chatbot? Eliza?
Ah, yes. Joseph Weissenbaum, 1966. Eliza. The world's first chatbot, really. It was surprisingly effective at mimicking conversation.
What was so surprising about it back then?
Just how readily people attributed real understanding to it, Even though it was running on pretty simple rules, it showed something about us how we project intelligence.
Interesting. But it wasn't all smooth sailing, was it? I've heard about AI winters.
That's right. After periods of huge excitement, you had these winters, mainly in the 70s and 80s.
What happened?
Basically, the hype got way ahead of the reality. Predictions weren't met, funding got cut, progress stalled, limited computing power, and not enough data were big factors.
Yeah, reality check.
Yeah, and this cycle of boom and bust, optimism and disillusionment, it's kind of a recurring theme in AI's history.
But obviously, things picked up again. The 80s saw a comeback with expert systems.
Exactly. Expert systems were a big driver. Like DC's XCon system helped configure computer orders and save them a fortune millions annually. That showed real practical value.
All right, real ROI. And then came some big public moments. Deep Blue.
Ah, yes, 1997. IBM's Deep Blue beating Garry Kasparov at chess. That was huge.
What was the key takeaway there? Just that a machine could win.
Well, yes, but how it won was maybe more significant. It wasn't thinking like Kasparov. It was using brute force computation, evaluating 200 million chess positions per second. It showed the raw power of computing.
Mind-boggling speed.
Definitely. Then jump to, say, 2011. IBM's Watson wins on Jeopardy, which is about understanding natural language nuance.
Yeah.
And Apple introduces Siri, AI starting to feel more conversational.
Which leads us pretty much to the current era, right? The deep learning explosion starting around, what, 2012?
Precisely. This is when things really accelerated, largely fueled by better processors, GPUs specifically, and just massive amounts of data becoming available.
The big data era.
Exactly. Suddenly in 2012, AI could reliably recognize pictures of cats online. Sounds trivial, but it was a benchmark. By 2015, machines were actually better than humans at certain image recognition tasks.
That's a huge leap.
It was. And then a key technical innovation in 2017 was the transformer architecture. Doesn't sound exciting, but it's the foundation for most of the modern large language models, the LLMs.
Like ChatGPT.
Exactly. Before that, though, 2018, Waymo launched its self-driving taxi service. And then, late 2022, 2023, OpenAI drops ChatGPT.
And suddenly everyone was talking about AI.
It just captured the public imagination like nothing before. Its conversational ability was startling. Now, in 2024, things like GPT-4, Google's Bard, they're almost mainstream.
So looking back at that whole journey,
You really see AI shifting from this academic curiosity to a seriously practical tool, driven by data, better algorithms, way more computing power, and a big shift in how it learns from being told rules to learning patterns from vast, diverse data.
okay, so AI isn't just one thing. You mentioned machine learning and deep learning. How do they all fit together? Can you break down that family tree a bit?
Sure. Think of AI as the big umbrella term. Everything we're talking about falls under AI. Now, machine learning, or ML, is a major subset of AI. It's the part focused on algorithms that learn from data to find patterns and make predictions or decisions.
Okay, learning from data.
Right. And within ML, there are different styles. There is supervised learning, where the data is labeled like flashcards with answers, good for things like spotting fraud, where you have examples of good and bad transactions. Then unsupervised learning, where the AI gets unlabeled data and has to find structure itself, like grouping customers based on purchasing habits without being told the groups beforehand.
Finds hidden patterns.
Exactly. And there's reinforcement learning, too, where the AI learns by trial and error, getting rewards or penalties. Think teaching an AI to play a game.
Okay, AI, ML, different learning styles. Where does deep learning fit?
Deep learning, DL, is a subset of machine learning, so it's even more specialized. It uses those artificial neural networks we talked about, but with many, many layers, hence deep.
More layers means smarter.
It means it can learn much more complex patterns, especially from unstructured data like images, video, or raw text. It kind of figures out the important features by itself as it goes through the layers. That's the key automatic feature learning.
That sounds incredibly powerful. But it makes you wonder, are we talking about AI that thinks just like us or something different? You hear terms like weak AI, strong AI.
That's a really important distinction. Pretty much everything we have and use today is weak AI or narrow AI.
Narrow AI, meaning
Meaning it's designed and trained for one specific task or a narrow set of tasks. Siri can answer questions, but it can't, write a symphony or feel empathy. A chess program plays chess, period. It simulates intelligence for that job, but it doesn't have general understanding or consciousness.
so it's a specialist, highly skilled, but only in its domain.
Exactly. Strong AI or artificial general intelligence AGI is the hypothetical stuff.
The sci-fi version.
Basically, yeah. An AGI, if it existed, would have human equivalent intelligence, able to learn, understand, and apply knowledge across a vast range of tasks, just like a person. It would likely have self-awareness, but that's still theoretical.
That's uber intelligence.
Even more theoretical. ASI, artificial superintelligence, would be AI that dramatically surpasses human intellect in almost every way. But again, that's speculation for now. We're firmly in the narrow AI era.
Got it. And within AI development, are there different philosophies,
Yeah.
ways of building these systems? I think I've heard of a symbolic AI versus something else.
Yes, broadly speaking, there have been two main approaches. Symbolic AI, sometimes kind of classical AI or GOFAI, good old-fashioned AI. That approach relies on, well, symbols and rules. Programmers explicitly encode knowledge and logic, often as if this in that statements.
What's the advantage there?
Its decisions are usually quite understandable or explainable, you can trace the logic, but it's very labor-intensive to create and update those rules, and it struggles with ambiguity or learning subtle patterns from data.
And the other approach, connectionist.
Right. Connectionism is the basis for most modern AI, especially deep learning. It uses those neural networks. Knowledge isn't stored in explicit rules, but distributed across the connections between artificial neurons. It learns patterns directly from data.
So better at learning from messy, real-world data.
Much better. Great for things like image recognition, natural language, highly adaptive. The drawback: sometimes it's hard to know why it made a particular decision. It can be a black box.
The explainability problem.
Exactly, which has big implications. Though increasingly, systems are trying to combine both approaches, neuro-symbolic AI, to get the best of both worlds.
Fascinating. And within this big AI umbrella, there are all these specialized areas, right? Like branches of science.
Absolutely, several key branches. Natural language processing, NLP, is huge. That's about machines understanding and generating human language.
Chatbots, translation, Siri.
All NLP. Then there's computer vision, teaching computers to see and interpret images and video.
Self-driving cars need that.
Yeah,
Facial recognition.
definitely. And generative AI is the really hot one now.
Creating new stuff.
Yeah, creating new text, images, music, code, whatever, usually based on a prompt. ChatGPT, AI image generators like Midjourney or Della LE, that's all generative AI. It's driven huge interest, but also big ethical questions.
It's like misinformation or AI hallucinations.
Precisely, where it makes things up convincingly. Other big branches include robotics, physical machines acting in the world. Expert systems are still around specialized problem solvers. And fuzzy logic deals with uncertainty, like in control systems.
Wow, okay. So if you're listening, the key takeaway here is AI isn't one single brain. It's this diverse toolkit, right? Lots of specialized tools for specific jobs.
That's a great way to put it. And the reality is you're probably using a bunch of these tools every single day, maybe without even thinking about it.
Right. This is where it gets really interesting. It's not future tech, it's now tech. And mostly that narrow AI we talked about, like recommendation systems, we use those constantly.
Oh, absolutely. Netflix, YouTube, Spotify, Amazon, they all use AI. It analyzes your viewing history, your listening habits, your purchases, and compares it to millions of other users to predict what you might like next. It learns your tastes to keep you clicking, watching, buying.
It's scary how well it works sometimes. And digital assistants. Siri, Alexa, Google Assistant.
Pure AI. Using NLP for speech recognition, understanding your commands, searching for info, controlling smart home devices, and chatbots on websites for customer service. Same deal, often trained on huge logs of past conversations.
ChatGPT is just a super advanced version of that.
Essentially, yeah. Much more sophisticated model, much more data, leading to that remarkable fluency. And then autonomous vehicles.
Self-driving cars, Tesla's autopilot, Waymo.
Right. They use a ton of AI, computer vision to see the road, sensors like radar and LiDAR, AI algorithms processing all that data in real time to make decisions, steering, braking, accelerating.
Waymo's robo-taxis are actually driving people around in some cities now, aren't they?
They are. Millions of autonomous miles driven. Even if your car isn't fully self-driving, features like adaptive cruise control, lane keeping assist, automatic emergency braking, that's all AI working behind the scenes.
It's becoming standard, but goes way beyond just our personal gadgets and cars, right? What about other industries? Healthcare comes up a lot.
Huge impact there. AI helps analyze medical images, X-rays, MRIs, potentially spotting things radiologists might miss. It can analyze patient data to help predict disease risk or suggest personalized treatments. IBM Watson famously worked on cancer diagnosis and robotics assisted surgery.
Finance, too, I imagine. Fraud detection.
Absolutely critical. AI algorithms sift through millions of transactions to spot suspicious patterns indicative of fraud or money laundering. It's also used in algorithmic trading, risk assessment.
Retail. E-commerce.
Everywhere.
Yeah.
Managing inventory, dynamically adjusting prices based on demand, powering visual search where you upload a photo to find a product, those ever-improving customer service chatbots, even cashierless stores like Amazon Go.
And manufacturing. Industry 4.0.
Big time. Using AI for predictive maintenance, figuring out when a machine is likely to break before it happens. Using computer vision for automated quality control on assembly lines. Optimizing incredibly complex supply chains.
Transportation, logistics, route planning.
Hyper-efficient route optimization for delivery companies. Education is exploring personalized learning platforms tailored to each student's pace. Cybersecurity uses AI constantly to detect new threats and automate responses.
Even farming?
Yep, agriculture. AI-powered drones analyzing fields for disease or pests. Smart irrigation systems using only the water needed. Monitoring livestock health. Precision agriculture, they call it.
And entertainment beyond recommendations.
Oh, yeah. Assisting with visual effects in movies, creating more realistic characters in video games, even generating scripts or music. Enhancing VR and AR experiences, it's really touching almost every sector.
Okay, so the impact is undeniable, it's powerful, it's pervasive. But let's talk myths, because
Yeah.
the hype, like we said, gets wild. Myth number 1, AI is going to take over the world. Skynet is coming.
Right. That's pure science fiction, at least based on anything we have today or foresee realistically. Today's AI is narrow, it's specialized, it doesn't have consciousness, self-awareness, or its own goals. It follows code. It's a tool.
Okay, reassuring. Next myth.
Yeah.
AI is always super intelligent and never makes mistakes. People seem to think it's infallible.
Definitely not true. AI is only as good as its programming and, crucially, the data it was trained on. It doesn't understand things like humans do. It finds patterns. It can absolutely make mistakes.
Right.
Misidentifying images, weird translations, generating incorrect information, those hallucinations we mentioned. If the training data was bad or biased or incomplete, the AI's output will reflect that.
Yeah.
Garbage in, garbage out, basically. It doesn't know things in our sense of knowing.
Right. And the third myth, AI doesn't need humans anymore, or it just learns completely on its own.
Also false. Humans are essential. We design the systems, choose the algorithms, collect and prepare the data, train the models, evaluate the outputs, fine-tune them, decide how they're deployed. AI augments human capabilities. It doesn't replace the need for human judgment and oversight.
So it can't really understand context or common sense, or be truly creative.
Not in the human sense, no. It operates on patterns learned from data. It lacks deep world understanding or intuitive reasoning. It can generate novel combinations of things it's seen, which can look creative but genuine, out-of-the-blue innovation. That still seems uniquely human. And things like emotional intelligence, empathy, intrinsic motivation, like AI doesn't have those.
And technically, there are still big hurdles, right? It's not perfect tech.
Far from it. Data is a huge one. AI needs vast amounts of high-quality data. Biased data leads to biased AI. That's a massive problem in areas like hiring or loan application.
The bias issue is huge.
It is. Then there's the black box problem we touched on. For complex models like deep neural networks, it can be really hard to understand exactly why it made a specific decision. That lack of interpretability is a major challenge, especially in high-stakes areas like medicine or law.
If you can't explain it, how can you trust it? Or fix it when it goes wrong?
Exactly. Plus, training these big models takes enormous amounts of computing power and energy, which has environmental implications. And they can be vulnerable to adversarial attacks, basically, tricking the AI with carefully crafted fake inputs.
So technical limits, and these tie right into the ethical considerations, don't they? Bias, fairness.
Directly. If the data reflects societal biases, the AI will learn and potentially amplify them. We see this in facial recognition, having trouble with certain demographics, or biased algorithms in criminal justice or hiring.
Privacy is another big one, with all that data being collected.
Massive concern. How is data collected, used, stored, protected? What about facial recognition databases? The potential for misuse, like deepfakes? GDPR and other regulations try to address this, but it's complex.
And accountability. If a self-driving car crashes or an AI medical diagnosis is wrong, who's responsible?
That's a huge question. The developer, the deployer, the user. Tracing decisions in complex systems is hard. There's also the longer-term AI control problem, ensuring that future, potentially more powerful AI systems remain aligned with human values and don't cause unintended harm.
Transparency seems key.
Absolutely. We need transparency about what AI can do, its limits, the data it uses, and how decisions are made as much as possible. This whole area raises a critical question, really. How do we balance this incredible potential with the very real limitations and the profound ethical challenges? That link between technical choices like using black box models and societal problems like lack of explainability is vital to grasp.
That's the tightrope we're walking. Looking ahead then, what are the big trends shaping AI's future? What's coming next?
Well, one big area is multimodal AI. Systems that can understand and integrate information from different sources at once: text, images, audio, video, kind of like how humans perceive the world.
So AI that can watch a video, listen to the sound, and read captions all together.
Exactly. That could lead to much richer understanding and interaction. Imagine better autonomous navigation or AI that helps diagnose illness by analyzing visual scans, patient history text, and recorded symptoms.
What else? Agentic AI.
Yes, that's another major trend. Think autonomous AI agents that can perform complex tasks over time with minimal human input. Not just chatbots, but agents that can, say, manage your calendar, research topics, monitor systems, maybe even execute multi-step plans. They'd have memory and learn continuously within their domain.
Like having a superpowered digital assistant for specific roles.
Sort of, yeah. We're also seeing continued hyper-personalization across services and ongoing development of specialized computer chips, ASICs, just for AI, because the computational demands keep growing.
This all sounds like it's going to drastically change how we work. What about human-AI collaboration? Is it just about robots taking jobs?
It's much more nuanced than that. AI is transforming roles, but often by augmenting human capabilities, not just wholesale replacement.
Augmenting how?
By automating the routine, repetitive, data-heavy parts of a job. This frees up humans to focus on the things AI can't do well: creativity, complex problem-solving, critical thinking, interpersonal skills, strategy. Some research even suggests AI might boost productivity more for lower-skilled workers by helping them perform tasks faster or better.
So it helps us make better decisions too.
Definitely. By analyzing vast data sets, AI can provide insights and predictions that humans might miss. We're seeing these virtual you agents emerging: AI helping draft emails, summarize reports, suggest talking points, and goal-based agents that analyze data to spot trends or predict outcomes to help achieve specific business objectives.
There's even talk of people managing agents.
It's being explored. Could AI potentially automate some supervisory tasks or handle routine management functions? That could lead to flatter organizations. The future seems to be about human-AI teaming, or HAT.
Teaming, like colleagues.
In a sense, dynamic partnerships where AI might act as an assistant, a coach, a mentor, or a peer, depending on the task. But that requires careful thought about how much autonomy to give the AI, who's responsible for what. It's complex.
Which brings us back to governance. With all this potential power and integration, governing AI ethically seems absolutely crucial.
Non-negotiable. Given the risks exacerbating inequality, privacy invasion, unaccountable decisions, strong governance is essential.
What does that look like?
It means adhering to ethical guidelines, complying with laws like GDPR or the EU AI Act, managing risks, ensuring human oversight, actively working to prevent and mitigate bias, demanding transparency, and maintaining control.
Why is it so important?
It's about preventing harm, ensuring AI is safe and reliable, establishing accountability, building public trust, which is vital for adoption, defending against misuse, and helping create sensible global standards so we don't have a chaotic free-for-all.
And how do organizations achieve that?
Through things like involving diverse voices in development, being clear about AI's role and limitations, training employees on ethics and bias, creating internal ethical frameworks and review boards, and really prioritizing fairness and safety from the design stage onwards. It shows how tech progress forces us to confront these deeper societal questions. Responsible AI needs ethical frameworks, regulation, and human oversight baked in from the start.
Okay, let's try to wrap this up. We've covered a lot. So, quick recap. AI, basically computers doing tasks that need human-like smarts, uses algorithms, learns from data.
Right, and its history goes way back from Turing to today's chatbots and self-driving tech.
And crucially, it's not magic. It's
Right.
powerful, yes, but specialized, not all-knowing, not infallible. It makes mistakes.
And it's fundamentally a human creation. It follows our rules, learns from the data we give it. It can do incredible things, but it's a tool.
So the big question we want to leave you, the listener, with is, how are you going to engage with this technology as it evolves? It's in your phone, your car, your workplace. What responsibilities do we all have to make sure it develops ethically and benefits everyone? What stands out to you about its potential or its challenges?
Lots to think about. And in our next deep dive, we're planning to get even more into the weeds of how some of this tech actually works.
Yeah, we'll dig deeper into things like machine learning models, how neural networks actually learn, and tackle some emerging issues around AI ethics and the future of work more directly. So stay tuned, plenty more to explore in the world of AI.